Hose A takes 3 hours to fill the tank. Hose B takes 5 hours to fill the tank. If both hose A and hose B are used from the beginning to fill the tank, but the tank also contains an open drain which can empty the tank in 6 hours, how many hours will it take for the hoses to fill the tank? So I always recommend drawing a picture for these types of questions just to be able to visualize what's happening. Hopefully it'll make it a little more clear. So we have a tank and we have two different water sources that are being pumped into this tank at the same time. We have hose A, and that requires 3 hours if it's working by itself to fill the tank. And again, we have hose B, and by itself, it would take 5 hours to fill the entire tank. But now, one thing that is kind of crucial to this question is it also contains an open drain by which the drain can empty the tank in 6 hours total. So we have this big hole down here and it's leaking water, and we'll call this D for drain. D, it could drain the whole thing in 6 hours. So what we have here is a work equals rate times time question. W equals RT, and hopefully this looks somewhat familiar to you. And if you take physics, then you're probably really comfortable with this. What we're going to do is we're going to make an equation for A, B, and D separately, and then we'll see how we can use them all together. So we have the work that A does is equal to the rate that A works times the T that A works. The work being done is just filling the tank up. So let's just call that 1 unit of work. We don't know what the rate of that is, but we know that it takes 3 hours. So the rate that hose A is working is 1 tank per every 3 hours. Next we have the work of B, and we have the rate of hose B times the rate of the time that it takes hose B to do the work. And again, it's filling the tank, which is just really 1 unit of work. So we can plug in what we know and we figure out that RB is equal to 1 divided by 5. Finally, we have the work that the drain is doing, and in this case it's leaking it out, but we have RD times TD, I'm sorry. Again, the work being done is 1, and the rate that it's doing it, that's what we need to figure out, but it takes 6 hours, so RD is equal to 1 over 6. Now what do we do here? The question is, how many hours will it take for the hoses to fill the tank? But we have to keep in mind that water is still exiting the tank simultaneously. So the rate that the two hoses are filling the tank would be the rate of A plus the rate of B, right? But the rate that it's leaking out, we would have to subtract RD. So basically we need to figure out R net. R net would be whatever is in this case, that's RA plus RB, minus whatever is out, which is the rate of the drain. So we get 1/3 plus 1/5 minus 1/6. If we get a constant or a lowest common denominator, get 10 over 30 plus 6 over 30 minus 5 out of 30. We get 16 over 30 minus 5 out of 30, so that's 11 divided by 30. That would be the rate that water is actually filling up the tank. So again, what R net means is hose A and hose B, they're both pumping water in, but we know that this drain is leaking out. So we know that since everything is working at the same time, 11 over 30 would represent how much water is actually being filled, or the rate that the water is actually filling up the tank with all of those three things occurring at the same time. So finally, since the question is asking how many hours will it take for the hose or for the hoses to fill the tank, we use our W equals RT equation one last time. The work, it's filling up the tank, which is 1 again. R is equal to 11 over 30 times T, and T would then equal 30 over 11, which is our final answer. In this case, if you needed to figure out what that is, that'd be 2.6 72 repeating hours, which would be the final answer. So again, for any of these work equals rate times time questions, make sure that you use this basic formula. Next, if you have multiple things happening, you want to make up multiple W equals RT equations. And again, you want to think about what's actually really happening here. A and B are both having water go into the tank, but again, the drain is having water exit the tank. So really what we need to figure out is how much water is actually filling the tank, which is the water going in, and we subtract the water that is going out. So we get R net. After we get R net, we plug that into this W equals RT equation one last time and solve for T.